Hi guys, welcome back to my channel. Myself, I'm Tejas from SVC. Today we're going to discuss about applications of vector calculus in real life, exploring the wonders of vector calculus. Have you ever wondered how the principles of calculus apply to our everyday lives? Join into the world of vector calculus and discover its hidden applications in science and engineering. Real life problems that require calculus. Medical applications. Understanding how drugs interact with the human body requires a deep understanding and using calculus to maintain the dynamics of drug absorption. Economics and finance. Maximizing profit and minimizing risk entails complex mathematical models that exploit the use of derivatives, integrals, and vector calculus to predict the market trends. Space travel. Navigating through space requires a series of complex calculations, including vector calculus, to determine the correct trajectory and position of spacecrafts. Game development. In a video game simulation, calculus and vector calculus are used to create realistic animations of movement, gravity, and collections. Introduction to vector calculus. What are vectors? We will introduce scalars and vectors and see how they relate to physical quantities like speed, velocity, and force. We will also introduce common operations like dot, product, and cross product. Calculus on vector fields. We will look at the role of limits, partial derivatives, and gradients of vector fields. We will introduce some of the basic theorems of vector calculus, including fundamental theorem and the gradient theorem. Applications of physics and engineering. Electric and magnetic fields. We will explore how vector calculus contributes to the theory of electric and magnetic fields. From Gauss law to Ampere law, circular law, we will understand how vector calculus helps solve to most of complex problems in electromagnetism. Second one, fluid mechanics. We will explore fascinating world of mechanics through the lens of vector calculus. From Reynolds transport theorem to steam function, we will see how vector calculus helps us understand and model the dynamics of fluid flow. Third one, optimization. Optimization problems of often arise in engineering applications. Here we will see the calculus and matrix operations combined to shape that landscape of optimal control and optimization theory. Maxwell's equation and electromagnetic fields. Maxwell's equation. Maxwell's equation are foundation of electromagnetic theory. We will explore how Gauss law, Faraday's law, and Ampere's law can express using vectors calculus. Next one, electromagnetic waves. We will learn how vector calculus plays a crucial role in understanding the nature of electromagnetic waves, which are invisible to the naked eye but govern the behavior of light, radio waves, X-rays, and other forms of electromagnetic radiation. Third one, applications in telecommunications. Finally, we will see how vectors help engineers design radio towers and cellular phone networks that reliably transmit data and information around the globe. Conservation laws and their applications. First one, conservation of energy. We will explore how the principle of energy conservation arises in physical systems and how the calculus of vectors can be used to solve the problems related to the energy transfer and conversion. Second one, conservation of mass. We will examine how the principle of mass conservation is used to understand and solve problems related to fluid mechanics, chemistry, and other areas of study. Third one, conservation of momentum. Finally, we will study how momentum conservation plays a crucial role in physics and how vector calculus enables us to make accurate calculations related to the transfer of momentum and force. Vector calculus in fluid dynamics. In that first one, the Navier-Stokes equation. We will introduce the Navier-Stokes equation and their role in fluid mechanics problems. We will discuss how vector calculus and numerical methods combine to stimulate and understand the dynamics of fluids. Second one, turbulent flows and aerodynamics. We will use vector calculus to be understand behavior of flows, including the formation of vorti- vortices and turbines, and explore the application of vector calculus in the design of aircraft and engines. Third one, oceanography and meteorography. We will discuss how vector calculus is applied to the study of large-scale fluid dynamics in the atmosphere and oceans. From ocean waves to climate modeling, we will understand how vector calculus can contribute to the vertical modeling and forecasting systems. Conclusion and future research directions. We conclude by observing the vector calculus is a fundamental mathematical framework that has revolutionized the way we understand and model complex systems. Its applications can be seen in every area of science and engineering, providing a key tool for solving today's most challenging problems. Look to the future. We are optimizing that vector calculus will continue to propel the development of new technologies and the discovery of new fortunes of knowledge. Thank you, guys.